Okay, sample spaces, and this is kind of a video on the introduction to probability. So let's say your your experiment was having three children in a family. So in this case, you have eight choices. You could have all three being boys. You could have two boys and a girl. You could have a boy, then a girl, then a boy. You could have a girl, a boy, and a boy. You could have all three girls. You could have a girl, girl, and a boy. You could have a girl, boy, girl. And you could have a boy, girl, girl. And hopefully I have eight of them there. Because there's eight possibilities for having three children. So 1, 2, 3, 4, 6, 7, 8. And as long as I didn't overlap any, we got them all. So that's the sample space for a family with three children. These are all the possibilities that they could have had. So let's go to something a little simpler. How about just rolling a dice? Well, if you have six sides, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So that's the sample space for rolling one dice. Okay. Flipping a coin. Flipping a coin is as simple as either it's a tail or a head. So there's your sample space for flipping a coin. I usually put these little brackets around them to represent the set. Flipping two coins, well, here you could have tail, tail, head, head, tail, head, or head, tail. And there's all the possibilities for flipping two coins. Okay, how about flipping a coin and rolling a dice? Well, there you could have tail 1, tail 2, tail 3, tail 4, tail 5, tail 6, or you could have head 1, head 2, head 3, head 4, head 5, or head 6. So those are all of your sample spaces for flipping a coin and rolling a dice. That's all the possibilities we could possibly have. Okay, drawing a card. I'm not going to list these out. If you have a deck of 52 cards of standard deck, poker deck, with hearts, clubs, you've got four choices. You've got hearts, clubs, diamonds, and spades. You've got ace, king, queen, jack, and then all the number cards from deuce on up to 10. And I think I just covered them all, but there's 52 cards in that situation. And we'll do things with that later. And you could also have a situation where you roll two dice. Well, the sample space for rolling two dice, so let's see if I can just find it quickly here. I need it in my contents. There it is. I'll drag it out here. And so there is the sample space for rolling two dice. So you could get a 1-1. That's what that one represents. This one's a 4-4 or a 3-5 or a 5-3. So those are all the different possibilities for rolling two dice. And notice there are 36 of them if you count them up. 36 possible. Here's your first dice, its possibilities. And here's your second dice and its possibilities. And so there you go. So there's the sample space. So what to do with sample space? Well, once you have the sample space, it's very easy to figure out the probability. Probability, if you want to think of it in terms of symbols, probability of event E happening is figured out as the number of outcomes of E divided by the total number in sample space. Kind of ran out of room there, so And so that's it. And it's usually expressed as a reduced fraction or a decimal or a percent. Definitely between 0 and 1. So here's one. Find the probability of drawing a king in a standard deck of 52 cards. All right, so there are 4 kings in a standard deck. And here's how you could probably represent that. Probability of K, or maybe probability of king. A lot of times you'll see it this way in a book. So the probability of getting a king would be there are 4 kings in a deck: the diamond, king of diamonds, king of spades, king of clubs, and king of hearts. And there are 52 cards. Okay. Then you'd want to reduce that. So 52 divides by 4 evenly. So that would be 13. So 1 and 13 cards in the deck is a king. So that would be the probability. Now you could also, 1 divided by 13 and is 0.077 approximately. 0.077 or 7.7% approximately. So those are all 3 ways of representing the probability of drawing a king. All right, so let's look at some of the others here. Find the probability that you have 3 children that are all girls. Well, the only chance you have of that is 1, and if you remember, there are 8 in the sample space. So let's just take a look at that. Here it is. So here's my all girl. Where's it at? There it is. So there's my success, all 3 girls. But there were 8 total possibilities. 1, 2, 3, 4, 5, 6, 7, 8 in the outcome. And you want to be careful not to confuse probability with odds. We'll talk about odds in another day. But odds are done differently. They are successes over failures. But this is successes over total, essentially, for probability. Find the probability of drawing the 10 of diamonds. Well, there is only 1 10 of diamonds. It might do something like this: 10 diamonds. Okay, and there's only 1 10 of diamonds in a deck out of, not 10, out of 52 cards in a deck. And so your probability is 1/52. Find the probability of rolling a 7 on a dice numbered from 1 to 6. Okay, that's a trick question. Well, probability of that occurring, probability of a 7 on a 6-sided dice is 0 if you number them 1 to 6. So you got a 0% chance or 0 chance of having that occur. All right, so that's basic probability. Now, there's another part of this that's very useful, and that's complementary events. So 3 girls in a family with 3 children, well, the complement of that would be all the rest, the other 7. So boy, 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 girl, boy, girl, boy, girl, boy, boy, girl, girl, boy, girl, boy, girl, and boy, girl, girl. That would be the complement. So there's 7 of them. Rolling a 6 on a dice numbered 1 to 6. So the complement of that would be 1, 2, 3, 4, and 5. So there's 5 possibilities for the complement of that. Or drawing a red card. Okay, drawing a red card. You could also draw a black card. So a black card, as I write in red, would be the complement of that event. And how we represent that is if our event is E, then the complement would be P of E bar. So that's how we represent the complement of event E. Now, probability of event E is 1 minus, or E bar, is 1 minus the probability of the event actually happening. So for instance, let's go back to, I think the boy girl boy thing is the three children is kind of the nicest one. So if our event E is three girls in a family having three children, and we want to find the complement of that, okay? Well, we already know that the probability of E, three girls in a family and all three for all three children, is 1 out of 8 possibilities. So the probability that of E bar, the complement of this happening, so all the other possibilities, is 1 minus 1/8 or 7/8. And you could get that pretty quickly by just looking. There's, count them up. There's seven here. Count all these up out of the 8 possible. So that would be the complement of that one. Here, if the complement of this one, let's say we call this one E. So rolling a 6 on a dice. So the probability of E bar, the complement, or rolling a 1 through 5 would be, well, it's 1 minus 1/6 or 5/6. Then you can also count them here. There's 5 of them out of 6 total possible. Drawing a red card, the probability of this event, well, there's 52 red cards, and so if E were this, our event were this, drawing a red card, the probability of E would be 26 out of 52, which reduces to 1/2. And so the probability of E bar would also be 1/2 because we take 1 minus 1/2. And we also know this, which is 1/2. And we also know this as there are 26 black cards. So, complements are very handy in certain situations, and we'll use them quite a bit throughout. And that's pretty much all we're going to talk about. There's other things, but I'll let you problem solve your way through those. So good luck, and hope this helps. See you next time.